guys, today we're going to be adding and subtracting radicals. We worked a little bit with multiplying or product rules and quotient rules for radicals and simplifying radicals on Tuesday and Wednesday. So we're going to add a little piece here today. You'll probably pick up pretty quickly. The idea is pretty easy. So with this, though, you have to be able to simplify radicals like we have been doing. So there will be a little bit of that, but hopefully you'll be able to get through this video, kind of understand it, and get going on the homework and have a good understanding for when we start section 3 on Friday. So here we go. Radicals with the same index and radicand are called like radicals. So this is important, and I didn't want to move that. So like radicals work a lot like terms. We can add and subtract like radicals in the same way we combine like terms using the distributive property. So when we have radicals that have the same radicand and the same index, well, what does it mean by index? Well, that's when we're talking about if it is, okay, the square root of n. The index technically there is 2. We don't ever write it. Another example of index would be if it was the cube root of n. Okay, so for them to be like radicals, they need to be matching out here and in here. So it needs to be both of those that are the same. And that's when we consider them to be like radicals. And we can work with them to combine like radicals. So let's look at some examples. Most of today's notes are just examples. So I would write them down just to have something to refer back to. If we have questions over it, we'll definitely go over it on Friday. So here are our first 3 examples. We're looking at 5 times the square root of 7 plus the square root of 11 minus 8 times the square root of 7. So what are my like radicals? Well, they have to have the same index. All of these have the same index, but they also have to have the same radicand. So the only ones that have the same radicand would be 7 and 7. So I'm going to move those by each other. What we have here is 5 times the square root of 7 minus 8 times the square root of 7 plus the square root of 11. I just moved it around to put my like terms by each other. So what we can do is pull them apart, pull the pieces out in front apart, and actually subtract these. So what I'm going to do is 5 minus 8 times the square root of 7 plus the square root of 11. So then I can just subtract. What is 5 minus 8? Negative 3 times the square root of 7 plus the square root of 11. So this would be my simplified answer because that is as simplified as I can go. I don't have another like radical, and both of my radicals are as simplified as possible. So you may be looking at B already and thinking, well, there's no way that I can combine those two. They're not like terms. But we can simplify the square root of 20 to make it possible to have some like terms. So let's look at this. We have 10 times the square root of 5. If I break apart the square root of 20 with a perfect square, I would have 4 times 5, or the square root of 4 times the square root of 5. Well, the square root of 4 is actually 2, so I would have 2 times the square root of 5. And now, look what I have. I have like radicals. So I can add pieces out in front. Oops. 10 plus 2 is 12. That's the square root of 5. Okay. Hopefully you're kind of picking up some of this as we go. All right, so let's look here. We have the square root of 3 minus 2 times the square root of 2 plus 6 times the square root of 2. So look for your like radicals. That would be my 2's there. So what I have is negative 2 plus 6 is what I'm going to be kind of bringing together. So negative 2 plus 6 times the square root of 2, because these are my like radicals. So square root of 3 plus 4 times the square root of 2. All right. "23 here. So check for like radicals. This would be my like radicals. So I'm going to move those by each other just to make life a little bit easier. So I just rearrange the order. So now I'm going to pull out the front, both of those. It's like the distributive property in reverse. So I have 13 times the square root of 2 minus the square root of 6. Can't go any further, nothing else can be simplified. Okay, this one kind of looks like we don't have like radicals, but if we were to take 63 and break it out, simplify that radical, what we would end up with, well, the square root of 9 is 3. 6 times 3, so I'm just going to write that out so you see what I did. The square root of 9 is 3, so now I have 4 times the square root of 7 minus 18 times the square root of 7. Now I have like radicals, so I have 4 minus 18 times the square root of 7, which would give me negative 14 times the square root of 7. Awesome, so I want you to try a few on your own. So these next two, I want you to go ahead and try. Pause the video, do what you need to do to get these done. Okay. So after you get these done, go to the next slide here. I have the answers here. These are the answers to 1 and 2. That's not what I meant to do. So here's number 1 and here's number 2. If you completely do not understand what I did or how I got there, I would go to your book. At the end of section 1, it goes over adding and subtracting radicals. There's a little section on it. You can kind of look at your book and see if you can figure some more information out. If you still are confused, not quite sure, you could wait till Friday to kind of talk to me. I will be in the gym on Friday morning, and I can talk with anyone that needs any help on some of this. Otherwise, you can go ahead, grab your homework. It's a worksheet over adding and subtracting radicals. Again, if you have major questions, don't worry too much about it. We will go over it on Friday. See if you can consult your book and see if you can kind of find some answers. Otherwise, maybe rewatch the video and see if you can find where you're kind of missing some information, but I think it's pretty self-explanatory. All right, guys, have a great day. We will see you tomorrow.